Okay, hello everyone and welcome back. Let's continue with Scikit-learn for training a linear model. See, there are several packages on Python which can be used for machine learning tasks. One of them, which will be used a lot this semester, is Scikit-learn. Scikit-learn is one package which consists of several models. You have seen some of these models. We will see some others until end of the semester, and there are many, many models that we do not cover. Scikit-learn can be used for the training a linear regression model. We want to call the linear regression because inside the Scikit-learn, first we have to import the Scikit-learn, and we did for other packages that we talk about today. But inside the Scikit-learn, there are several sub-libraries, and when we want to access to that sub-library, instead of doing this step by step, means first importing a Scikit-learn, then inside the Scikit-learn, one more line for importing that sub-library, we can do all of them in one line of the code by using the keyword from. You can say that from a Scikit-learn dot, when we were dot, it means that we are accessing to that sub package inside the Scikit-learn, and we will import linear regression. By running this, as you can see, linear regression will be imported into your Python framework. Okay, after importing these, then I have created a random data set for practicing and to see that how linear regression can be trained inside Scikit-learn. Inside NumPy, there are several tools which can be used to generate random numbers. When we want to do this, then we have one library inside the NumPy, which can be used for generating a random number. This library is random. Then here you can say numpy.random, and this random state that we use will be used for seed. Then any number can be written here. This is a seed variable. If I want to give you the very easy explanation of seed, seed is used because we want to make sure that every time that we run this line for making the random number, we do not reach to the different output. If you want to make sure that one set of random number will be generated, and next time that we run this code, a new set won't be generated, we can use this seed property. There are several random distribution numbers which can be generated. But when we write random.rand10, it means that we are generating 10 numbers between 0 and 1. As you can see, numbers that are generated here are denoted into NumPy array, and numbers are between 0 and 1. How you can get the numbers which are not necessarily between 0 and 1? By this line. For example, here when we write x equal to 10 times random.rand50, it means that we are generating 50 numbers which are between 9 and 10. By multiplying by 10, then we can get numbers, that between 0 and 10. By multiplying this by 10, you can get numbers between 0 and 10. If we want to see these, then let me run this code. And then y also can be defined by 2 minus x plus another set of random numbers, again 50 numbers. Then see, I define a function here. In this case, as you can see, x is 50 random numbers which are generated between 0 and 10. And here, as you can see, we are adding by defining this function 2 minus x plus another 50 random numbers, we can find another variable x and y. We can use some visualization tool that we have inside the inside the Pythons. One of them is matplotlib. As you can see in matplotlib, you can import this, and I import this as PLT. And after that, you can use these. As you can see, some histogram are denoted here for the dataset that we define at the beginning of our lecture today. But when you define these, you can see the points x and y that you have generated on the scatter plot. As this scatter plot shows us, it is clear that numbers that we define can be fitted on a line. It is not actually a big deal because we can see that based on the definition that we define for y, definitely we are defining a line. But we want to see that if this x and y that we generated randomly by using this are used for fitting a linear regression, how it can be done. I would like to explain a little bit about X that we have generated. As I explained, by using the line of codes that we have here, X is 50 random number which is generated between 0 and 10. And here we can see these values which are generated between 0 and 10. These are random numbers that we generated. As you can see, these numbers are stored in your computer by using NumPy array. And here we have a NumPy array. We want to use this data set as the input. And we want to use Y as the output. And after that, we want to train a linear model. Something which is important to understand is you cannot use X as the input of your linear model that you want to generate. Why? Because here X that we have here, as you can see, it has just a one-dimensional array. The one-dimensional array that you have, when you give this X as the input to your model, all of these values, all of these numbers will be considered as the input. But our goal is to define a linear function of dimension 1. Therefore, when we want to define a linear function of dimension 1, we would like to consider each of these values as one input separately. Since we want to use each of these these numbers as one input separately, then we can use another tool that we have in NumPy to add the dimension. NumPy.new access is one tool which is used in NumPy to increase the dimension. Here, as you can see, the dimension of this array is 1, and we want to increase the dimension. And when we want to increase the dimension by using the NumPy.new access, we need to remember that we increase by just adding one point to the dimension. Since this X has dimension 1, when we run this, we will get an object of dimension 2. And this line of code can be written as a row or as the column. In this case, as you can see, we are using this as column. Therefore, you will get the array which consists of these columns. And here, as you can see, now your array is two-dimensional. And as you can see, you have a matrix. This matrix consists of all of these rows. And as you can see, every row in this case consists of just one value. And you are defining the column which consists of some rows. Every row consists of just one value. This tool, mp.new access, is very helpful when we want to add one unit to the dimension of the new the data that we are using, and we want to use the same thing here. Then here, when we run this line x equal to x, the reason that we write here 2.common numpy.new access is that we want to define a column of vectors. And here, since we are defining the column of vectors, then here we will write this after comma. If we wanted to write the rows of vectors, it means that we want to define a vector with just one row and consist of some columns. In this case, we need to write this at the beginning. Okay. So then when we run in this, now X is defined and we can fit the model. When we want to fit the model, we will name the linear regression. Any name can be written here. Here we are using model. And here we want to have intercept. Then here we said that fit intercept true. This fit intercept is a Boolean variable which can be adjusted. By default, it is false, but we can make it true as we did it here. And after naming this linear regression that we are using here, we use a keyboard fit. It is that we will write model, the name of the model that we have generated here. And here we will write dot fit, since linear regression is an example of supervised learning, it means that in this case, input and output both should be given. That's the input and that's the output. As we explained in the supervised learning, when you are doing supervised learning, your data set should be labeled. And here, when we want to use the model which belongs to the supervised learning, you should give the input and output both to your model. And here, this is exactly something that we did. It means that that's the input, that's the output. And when we run it, one linear model will be generated. In this case, because X consists of these values, and here every X, every input consists of just one dimensional array here. In this case, we have these values. Therefore, the line that we will get consists of just one slope and one intercept. This slope and intercept here can be defined by A and B, and we can see these are slopes and intercepts which are generated. Therefore, as we explained before, when we want to generate a model, our goal is to have the mathematical object. Here, the mathematical object which has been generated is a line. And when we want to define a line in the one-dimensional space, it means that we want to have the line which consists of one slope and one intercept, and these are the slope and intercept that we generated. Okay, thank you.